Okay. I suggest to start our workshop. So I have the message here that, okay. Okay, we start our workshop and with ELSIROS and entry-level simulation of robotic of robots soccer, and we expect that the teams will send us their files in coming 1 or 2 days. And before that, I would like to explain how could be better to organize the files so that they could be easily linked to the games, and we shall start our tournament. According to the current situation, there are something like 11 teams now, and one team is from Belarus, other team from USA, and all the rest teams are from Russia. So if you already have downloaded downloaded ELSIROS to your computer, I think that most probably your computer is Windows, operate with Windows operation system. And so for this reason, I shall demonstrate my screen with Windows operation system. And so let's look how it could be looking the ELSIROS on your computer. Most probably it goes to the local disk C, and then in local disk C there is ELSIROS folder. Then we go into this folder and look what's inside of this folder. We shall see that here is controllers folder, game controller folder, prerequisites, protos, worlds, and some other files in this folder. So what is in worlds? Let's start from the worlds folder. In the worlds, there are the worlds which we can launch launch simulation, and here we see the ELSIROS game world. If we click on this ELSIROS game, then immediately game will be started. Let's click it on it, and let's look what's happening. Okay, so we see that WebBots simulation launched, and oh, sorry, something is interrupted, and then maybe because I clicked 2 times, maybe I need to click only 1 time, and then it will go. Okay, WebBots simulation started, and we see that spawning of the field. Now the world will be spawn players, 1 players, then altogether there will be 4 players spawned on the field. So after the players, we see that controllers of the players appears. So these 4 windows on the bottom, these are controllers of the players, and the last one, referee is coming and waiting for the referee, and as soon as referee will coming, then automatically the game will be started. We don't need to do anything for this, and the game will be started itself automatically. So okay, this is a game controller, and also immediately also some Windows Defender is asking us to allow things to go. We allowed them to go. Okay, so in the left upper corner, we see here, this is game controller. And with these buttons on the game controller, we can influence to the game if we want. We can, for example, penalize some of the players, or we can change the flow of the game, and all this possible with these buttons. But normally, during the competition, if human referee doesn't see anything strange with the games, then he doesn't touch to these buttons at all, because then in this case everything will be done by automatic autonomous referee. And so for this reason, currently we just minimize this window in order to be able to see what's happening on the screen. So if here are 4 windows related to each of the players, and for each of the players there are some messages coming, and these messages here I shall explain later where these messages appear from, and how they are recorded, and what's these messages are related to. Currently, we just also minimize these windows in order to see more what's happening on the scenario. So we see that the game is already in progress, and so for this reason, we can also see how quickly it's happening. So in order to understand how quickly happening the game, in the top window here is a speed of the game, speed of the simulation, and speed of the simulation is related to real-time development. So currently we see that speed of the simulation is jumping from 0.8 to 0.3. So average is about 0.6. So this is speed of the simulation. This is very good of speed of the simulation. Just for reference, speed of the simulation for the games which happen in Humanoid League for the academic students, speed of the simulation is 0.1. So it's very, very low speed. And so normally the games which between academic students are calculated during the something like 4 hours. So our game is running very quickly, and so we expect that we can finish game within 20 minutes. And so for this reason, so here we see the speed, and in the left from the speed we see the timing of the simulation. And normally the game development is following. For example, first time is 5 minutes, then second time other 5 minutes. If score is equal, 0-0 or 1-1 or 2-2, then normally also some extra time is added. So then is 2 times by 3 minutes are added. And if we see that 2 times by 3 minutes also lead to the equal score, then penalty shots are launched. Penalty shots means that each team has opportunity to make 5 penalty shots. And after this series of the penalty shots, if we see that again the score is equal, and then second series of the penalty shots will be launched. And after second series of the penalty shots, if we still see that score is equal, then the game is finished, because the next then we finish the game with the equal score, and then a human referee must have to decide if it's worth to also flip the coin to find who is the winner in the game, or just leave it the game with the equal score. So when game starts, let's say one team is playing with the red jackets, other team with the blue jackets. Normally team one is with red jackets and team two is with the blue jackets. And at the start of the game, one of the teams is granted for kickoff. And so at the start of the game, the team which is granted to the kickoff can approach to the ball immediately and kick it. And in the meantime, opposite team, which is not granted to the kickoff, must wait at least 10 seconds between entering to the central circle. If a player which is not granted to the kickoff enters to the central circle earlier than 10 seconds after starting the game, then this player must be penalized. What means penalized in this case? Penalized means that he will be placed to the border of the field for 30 seconds. And after 30 seconds, he will be allowed to enter to the game again. So what we see here, that the players are mix into the multiple collisions. When we see the multiple collisions, then simulation is slowing down. And if you see that, for example, if there is no collisions between robots, then simulation runs faster. And if there are collisions between robots, like now, then simulation runs slower. And this is the property of the simulator. And this is one of the negative points of the collisions. Of course, other negative points of the collisions is that if this type of the collisions happening with the leave robots can receive some damages. And so it is not very good if robots are colliding during the game. So for this reason, in this league, nevertheless, it is not penalized according to the current rules. But the league which is playing with the bigger robots, with academic students, the latest rules regulate collisions through penalization of the guilty robot. And so now we see that second time already started. And as you can observe, that blue team was granted to the kickoff, and a red team was waiting before entering to the central circle. So currently the game normally in distribution package we supply with two strategies of the teams. One strategy is latest strategy of the year 2021, and other one is related to the strategy which was played by the robots in 2020. And so why we do like this? Because if game happens between robots with exactly same strategy, then it will be difficult to see a successful game, because we will see a lot of strugglings between the robots, and most probably there will be very few very few goals achieved, and most probably there will be we will see that all the robots are behaving exactly the same. And for this reason, it is useful that teams could be running with the little bit different strategies against each other. Of course, if we see that the strategy completely different, then we will see most interesting game, because then there will be more goals scored, and also there will be more interesting development of the game. The fact that the game is running between robots with a different strategy doesn't mean that one team will be with the winning strategy and other one with the losing strategy. Sometimes even the team with the old strategy still can achieve the good scores, and so here is some kind of the randomization. So what means that randomization? Means that when we launch simulation, we can observe exactly the same development, or randomization means that development will not be exactly the same. So how this could be regulated? So we look into the left window here. Here is world info. And in this world info, if we open this world info, we can go and we see here a random seed. This field of the random seed currently equal to 0. And what means that random seed 0? Means that as soon as it has some certain value like 0, which is positive value, and means that each time development of the game, development of the simulation will be exactly the same. So when we launch simulation first time, it goes with a certain development, and when we launch the same simulation second time, development exactly the same. And it is if we, for example, put here in one of the simulation session value 0, and in another simulation session different value into this random seed, then we will see that development of the simulation is a little bit different from each other, because they have different initial values of the random seed. So if we would like that each time random seed to be different, then we can put here the -1, and then we will see that each time development of the simulation a little bit different from each other, with some new random number. So when you make training at home, it is useful that random seeds to be equal to each other in each game. Then you can see the difference between one game and different game when you make some changes in the strategy. So you can observe how these changes can influence to the game. So normally for training, random seed is better to be equal to each other in each game. But for competition, we shall put this random seed to -1. Because in this case, we will have more randomization of the games, which is useful for the teams when they are participating in tournament. So I put here random seed -1 means that in the next launch of the same game, it will be running a little bit different, not the same as now. So what kind of the other things could be workable here? I just show you some things, some tips. For example, here we see, oh, sorry. So here we go to preferences. And in these preferences, here is OpenGL. And in OpenGL, as you see here, I disabled shadows. What means disable shadows? I can try to enable it, but most probably it will be, yes, now we see the shadows. And as soon as we see the shadows, also we see that simulation a little bit became slower. And because now simulator spends more resources to calculate the shadows, and this is, of course, this is beautiful for point of view of the how it is look like, and but actually it is not practical for the if you want fast development. So I take shadows back again. So okay, and now we see that robots start playing a little bit faster. So during the competition, we shall delete the shadows because we have not so much time in computers during the competition time, so we will make the games without shadows. Of course, they are not so much beautiful as with shadows, but still we can see a result quicker, and the result doesn't depends on availability of the shadows. And so in the games where we have okay, game stopped actually because red team win 1-0, and this means that after this normally everything is closed by itself. But currently, what's happening currently, as soon as we have requested to make a video recording of the game, now video recording is under preparation, means that simulator currently is continuous running because it makes a recording of the video. And we don't need this video from this game, and so for this I just shut it down, and we discard changes because we need to proceed to the next points of our workshop, and, in which I shall show you how the files must be prepared for the competition. So we go to ELSIROS folder, and in this ELSIROS folder we go to controllers, And what we see in the controllers folder, here is a folder with the name sample team. So sample team folder is the folder where the source code for game for the controller of the players is located. So we can go inside and see that all these files are related to the source code of the controller of the players. So a controller of the robots. So this code here controls your robots. And the good style is that instead of make some changes, improvements, amendments inside of this sample team, you just keep the sample team as it is and just make a copy of this folder with the changing the name of the folder according to the name of your team. For example, we make just we make Control-C, Control-V. Okay, now we see that here is a new copy of the sample team, and we just change the name of the copy to let's say Baumek. Oh, sorry. Okay, now we have a copy of sample team, and inside of this copy Baumek, we can do whatever we want. We can change all these source codes in order to find a better opportunity to control robots. So all other folders and all other files here are not recommended to change, because in referee's computer they will be the same as here, and they will be exactly the same which you find them after installing distribution package. After installing distribution package from the after downloading, exactly the same files will be used on the referee's computer. And if you change something here on your computer, you can maybe you can improve some game, but it will not be the same environment in referee's computer. So the only folder is allowed to be changed. This is a folder which is related to your team's strategy. So this is a folder, and also one more file is allowed to be changed. Later I shall explain which file also must be changed in order to be presented for the tournament. This file is located in a referee folder. And in referee folder here, we see the file team1 JSON and team2 JSON. So these two files are related to the settings of the teams which will be played game. So team1 related to the team which is playing with the red jackets, and team2 is related to the team which is playing with the blue jackets. So in order to make to prepare your team JSON file, we take, for example, team1 JSON, we make a copy, Control-C, Control-V, and here we see the copy, and we rename it. Rename with team JSON. Okay, that's what you have to do in order to prepare your files for the competition. So team JSON, and then we open this team JSON and see what is inside. Okay, here is here we see the dictionary according to the according to the rules of the Python. This is dictionary, and in this dictionary we see the fields with the keys. So key name. Here is red team. Here we have to put the name of your team. Let's say Baumek. This name will appear on the dashboard of the game. Means that on the dashboard of the game, in the top level, we can see the names of the teams are playing, and also the name which we put here will appear on the dashboard. So the next field is robot start command. So robot start command. It was in this format, means that this is a location of the file which will be launched in order to control your robots. So as soon as we sample team, we rename to the Baumek. So we put here the Baumek. And in the folder Baumek, there is file main pb .exe. There could be two extensions for this file. Either it could be exe, either it could be py. Normally it is py because this is Python source code. So we currently we put main pb py. So when it works to put here exe. So exe means executable file in Windows. So in case if you doesn't want to share with referee your source code, you can compile your Python file to exe file, and then you clean out source code from your folder, and then in this case your source code Python files will not be transferred to the public. What means to the public? Actually, when you transfer your files, you just share the files with the referee. Of course, referee is a relatively independent person, and he is obliged not to share the files of the teams between each other. And but nevertheless, some of the teams could be nervous about leaking of the source code, and there is a tool that this source code could be compiled into the exe file, and then source code completely disappear from the reading. So in exe file, it is nearly impossible to read source code. So we go to the next fields. So now we see here the players. So totally in the game, there will be two players, player number 1 and player number 2. So according to the current rules of the games, we practice only with the 2 players in one team. Probably in future we shall decide that there will be more players, but in current season we decided the teams has decided that we start with the 2 players in one team. And so for this reason, we see here the 2 elements, elements in this dictionary players. So player number 1 and player number 2. So 1, this is number of the player, which will be printed on his jacket. So player number 1, here is a proto of the player. What means proto? Let's consider what means term proto. Proto is the model of the robot. Model of the robot, which is described in the language which is understandable by the simulator. So our simulator is Webots, and Webots accepts description of the robot in the file with the extension proto, and so these files are describing the complete structure of the robot. Currently, according to our current rule, we all use the same proto RoboKit 1, and in case if some of the team desire to use some different robot in their game, then they have to produce their own proto, and they have to provide the proto to the organizers and for approval. And this is additional special procedure how to approve the new proto of the robot. And this is complex and is not for the for the initial games. So for this reason, we skip it to the future. But currently we just for every player we put the proto with the same name, RoboKit 1, and it need to be placed by referee in ready. What means this field? Here the value of the field is true, and so thing is that in the game there are several states of the game. There is initial state, then there is a ready state, then set state, and then playing normal. So what means ready? In the state ready of the game, players are requested to proceed to their starting points. Means that initially players are located on the border of the field, and then in the next state the players are requested to proceed to the points on the field from which they will be starting the game. Means that, for example, if a goalkeeper is going to start the game in middle of the goals, then he has to proceed to this place by himself. But in case if he is not capable to do it, then a referee can put himself can put a robot by himself. Means that referee can do it instead of a robot himself. So for this reason we put here the true. Means that referee will relocate a robot from a border of the field to the coordinate in which the goalkeeper will be starting the game. So next field is a role. Role means that the players during the game they will have certain roles, and according to the roles of the players, the game will choose the controller will choose the module which is related to the role. So let's look where the role is. Where are these roles? So we see here the role is goalkeeper, and for other player in the same team, the role is forward. And let's see which kind of the roles are available for us at all. So I open the file with name. We go to the Balmec and then soccer, and here is file strategy. So okay, something went wrong. Okay, strategy is here. We go to the file strategy, And here in file strategy, with the line number 387 is a module play game. And in this module, we see various roles. Which kind of roles currently we have in our strategy. Role could be goalkeeper. Role could be goalkeeper old style. The role could be penalty goalkeeper, forward old style, penalty shooter, run test, rotation test, sidestep test, and dance. When this module meets the role, for example, goalkeeper, then the module goalkeeper main cycle is launched. Means that after this place, we go to the goalkeeper main cycle, and then strategy of this player with the role goalkeeper will be described in goalkeeper main cycle. So you see here's goalkeeper and goalkeeper old style. This we provide in a package in order that you could see that which strategy was used in year 2021 and which strategy was used in year 2020. So old style means that this is year 2020. And same for the forward. Here is forward and forward old style. Means that when we make training games on your own computer, so you can choose, for example, forward for one of the teams and forward old style for other of the teams in order to avoid struggling between the teams with the same strategy. So this is just for training, and normally, of course, it works to use the latest strategy, means that to use a goalkeeper or to use forward, and to make some improvements into these modules, and then these roles provide for the tournament. So let's go back to the team JSON, and in team JSON, after role, here we were describing what means the role, and the next is border starting pose. What means the border starting pose? So initially, a robot is spawned on the border, and means that this is state initial, and in state initial, robot just stands on the border for waiting for the next state. So this is position of the robot on the border. Translation means that this is coordinate of the robot according to the simulator system of the coordinates, and rotation is it's a rotation value of the robot, also according to the system which is used in simulator. Border starting pose, this is border starting pose. We see also here are some different ready starting pose, re-entry starting pose, shootout starting pose, and goalkeeper starting pose. What means each of these things? For example, ready starting pose. Ready starting pose, this is coordinate on a field where referee will put the player exactly before starting the game, and means that this is a border starting pose. This is position of the robot on the border, and ready starting pose. This is position of the robot inside of the field. Re-entry starting pose. Re-entry starting pose is used for re-entry after penalization. So during the game, referee can penalize robot, means that he can take him away from on the field and put him on the border, outside of the field. And after ending of the penalization time, normally this is 30 seconds, robot is allowed to return back to the field. And this is his re-entry starting pose, means that this is a point from which robot will be returning back to the game. And this is his translation and his rotation. So shootout starting pose. Shootout starting pose is used for penalty shots. Means that after finishing the main timing of the game, then the penalty shots are starting. And then the forward player, which is going to shoot the penalty, his position is on shootout starting pose. And goalkeeper starting pose is very easily understanding that this is position of the goalkeeper exactly before launching the game. So now we considered what kind of the data we have to provide with for the players number one, and the same similar description of the data for the player number two. So initially it is not recommended to change anything here, but in future, when you will see that you have already good skills with the strategy, you can also consider the changing of this data here. So we close this Team JSON by saving. We save Team JSON. And here I use Visual Studio because it is convenient to make changes into the Team JSON file through Visual Studio. So after we input the changes into the Team JSON file, we take this file into the same folder where the team's source code is located. So we just make Control X and go to the Baumec, and here Control V, and we see Team JSON moves here. So after we make this package prepare this way, now we're going to compress the folder. So I compress it with WinRAR. So we just compress it and okay, now after compression, we see that the folder is now baumec.rar, and its volume is about 21 megabytes. So, of course, it's not worth to send the file of this size through the email, and then the next step is that you upload this file through Google Documents, which is sent to you by organizer, and you should find in your email the reference to the Google Documents where you can upload this file to the referee's computer. So what kind of the else we can see here? I just explained some more little bit about meanings of the files which are located here, so that you could be easier for you to start understanding how to tune it. And here are the files: output 7001, output 7002, 7,021, 7,022. This is what means this output. During the playing the game, there are some messages from the controller, from the software. These messages are logged into this file. So after in this file, you can, if there are some problems, you can later you can look into this file and find what was happened before some troubles, and in order to understand what was the development of the controller during the playing the game. And so the main now I explain you how could be easier easy made tuning of the strategy. So I close this the Visual Studio and open once again so I choose a new folder. Oh no. Okay. So in the folder Baumek, yes, in the folder Baumek, there is a Python file, Strategy Designer. So let's try to open this Strategy Designer. I launch this Strategy Designer. Okay, here is Strategy Designer. What means Strategy Designer? Here we see the field, which is divided to the sectors. So in one section is normally this is a rectangle with the 20 centimeter by 20 centimeter. And when a ball is found to be located in a certain section, we can define which must be direction of the kick. So we can here, with using this utility, we can change direction of the kick. Here is, for example, yaw. This is direction. We can put take the slider to left and right, and then we can choose direction, desired direction, and this we choose the desired direction, and also the power of the kick. So here's the biggest power of the kick, but could be also smaller power of the kick. If we also drag this slider to the right, then we can find smaller powers of the kick. And so if we want to record the current chosen direction and the power that we just put on this record, then we can proceed to the different section and also choose in different section. And this is the way how we can make programming of the strategy without using any programming language. So this is the way how we can influence to the strategy of the game. So of course, in the package there is already ready strategy of the game, which is also described this way, and we can find it in the file. We load the file, and so we go to the controllers Baumec, and then we go to init params, and here is strategy data. So this strategy data, this is which is provided initially, and you see that here are directions of the kick, which are already designed by the developers of the ELSIROS software, and so we can see that the directions of the kick are quite smart. What means smart? For example, normally the goalkeeper is located in the middle of the goals. So in case if we kick directly to the middle of the goals, means that most probably we will not achieve the score, because goalkeeper will be saving the this kind of the ball. This is why it works to kick somewhere in between the goal post, which is here, and middle, where the goalkeeper is located. So it works to shoot somewhere in between of them. And we see that all these directions are located in order to shoot in between them. And there are several sections, for example, this one, this one, and this one, where it doesn't make sense to kick directly to the goals, because most probably we will not be succeeding in anything. And it makes sense to move the ball somewhere in better position. And this is why this direction means that the player will, by approaching to this place, he will make the light shooting to the middle of the field, and then from the middle of the field he has more chances to achieve the goal. So changing of these vectors, these are the vectors. Changing of these vectors can give you opportunity to change strategy of the game. And of course, this is easiest way of the changing of the strategy. And it doesn't mean that you have to know any programming language. You just have to be able to launch this type of the utility, and also after you make some changes here, of course you can you have to save your changes into the strategy file. You can do it by save, or you can do it by save and exit, and so we can make save and exit, and then we finish this utility. Just press any key, and then this utility is closed. So this is a simple opportunity to change strategy of the game. So what is the next level of the opportunity? Next level of opportunity is, of course, linked to the ability to program in Python language. So we open program which is located in soccer, and here's strategy Pi. So in this program, you see that here are a lot of comments, and this is specially designed in order to be for you to be able to understand what is how the program is built. So for this reason, in this program, if we can see how big is this program. It's about 800 lines. And you see that also a lot of comments is here. And of course, really executable lines are much less than 800. But actually, you don't have to scare from this number. Of course, the number is quite relatively big, but normally here are a lot of extra modules which are not useful for the study. And I shall just point which of the modules are useful to study in a first hand. So let's find here forward main cycle. So this is line number 495. This is forward main cycle. And this is the module which is describing the way of the playing by the forward. Of course, the forward is a most important person on a field, because forward is a guy who can achieve the goals, and depending on how good is his skills, then the more goals we can achieve. And so actually you see that the size of the module is not big. It's not more than 50 lines. It's just it is ending here, 543, and so not more than 50 lines actually. And even within these 50 lines, we see that a lot of lines are used for the comments. And let's try to understand what's the meaning of each line in this module, and in order to easier start with this programming. So first executable line is 501. So we start with the second player timer. What means second player timer? Thing is that there is a referee appoints the team which has allowed to kick off. So kick off means that the player is allowed to kick first the ball. And automatically this means that opposite team is not allowed to touch the ball, or even it is not allowed to enter to the central circle during the 10 seconds from the launching the game. And means that we have to respect this 10 seconds. And this is a reason that we launch a second player timer. Means that we launch this timer to understand when the 10 seconds will be over, in order to let the player to start moving and start entering to this central circle. So a second player timer, here in this line, we just check the current time. And in order to be able later to count 10 seconds and understand in which moment we are able to start moving. So this is a second player timer. And then the next line is 502. Here we just create instance of the class forward vector matrix. And this is just a new instance of the class, and this is just later we shall use this instance for the understanding the direction of the kick. So this instance of the class allowed us to calculate the vector of the kick from utility which were considered before. And the next line is while through. This is in infinite cycle. And so in this infinite cycle, we consider what's happening inside of this infinite cycle. First of all, we check falling flag. What means falling flag? We have many different modules of the software. Especially there are modules which are related to the motion. And this module of the software which is related to the motion, it is detecting if robot is falling position or robot is standing position. And of course, if it detects that robot is in falling position, immediately he changes the development of the software of the control in order to rise him up. So means that as soon as controller detects that robot has falling down, he stops current procedures, and he launch getting up procedure. So after robot has get up, the logic of the higher level must be capable to know is there was falling or was not falling. And as soon as falling was done, then then falling flag is raised. So means that if falling flag is 0, then means that there was nothing happened with the falling. And if falling flag is different from 0, then in this case we can the higher level logic will be able to know what kind of falling has been before. And so here is description about what kind of the values can be with this flag, and depending on the value, the higher level logic can understand that falling was done on his back or on his front, or he was falling on the left side or in the right side. And in case of falling flag comes with the value 3, means that actually this was happening because interruption of the program has been called by the human. So if human somewhere inside of the game pressed the stop button, then falling flag comes with the value 3. And in this case, we can undertake following measures inside of this higher level logic. So in case if falling flag is not 0, so in higher level logic, of course, we return it back to 0. And now the logic knows what's happened, and as a consequence of this, he changes, he reset coordinate. What means that reset coordinate? And because of course during the game our robot understands his own coordinate. How he understands his own coordinate? As soon as a robot make observation, means that he stops and start looking around. After looking around, he understands his own coordinate. And but in case he is not looking around, his coordinate can be less accurate. And for example, after falling down, for example, before falling down, robot knows his certain coordinate, but we understand that after falling down, coordinate could be completely different. Let's say after rising up to his legs to the standing position, coordinate can be a little bit different from initial one. And for this reason, we have to input this into the system, and this why here is coordinate falling reset, means that now a robot understand that his coordinate is not so accurate as it was before, and it is a little bit, it has to be more randomized around the place where he was falling. So the next operator is line 514. Here we see the module which is named seek ball impose. This is important module. We seek ball impose. During the seeking the ball in a pose means that a robot is standing and in stride position, and he just move his head into various directions. So totally there are 15 sectors. Actually, the field of the view of the camera is something like about 46 degrees. And this way it is not very wide, and this way in order to see the surroundings, he has to move the head to the left and right, to up and down, and totally there are 3 levels of the head where he moves in vertical, and 5 directions where he moves his head in horizontal, and 5 by 3 is 15. Totally it appears 15 sectors, means that he moves the head throughout all these 15 sectors seeking the ball. As soon as he finds the ball, and there could be 2 kind of the reactions. One kind of the reaction is fast reaction is on, and if fast reaction is on is true, then means that as soon as he finds the ball, he immediately interrupts his following seeking, and in this case he immediately interrupts, and he proceeds to the next operators. In case if fast reaction on is false, in this case this means that he doesn't interrupt his observation. As soon as he finds the ball in certain sector, he continue to look to other sectors. Why it could be useful that he continue looking to other sectors? For example, it could be useful in certain cases when he has enough time to do that, because during observation to the other sectors of the view, he can find also some obstacles, and not only the ball, he can find also obstacles, and he can find more objects in order to calculate his own coordinate. So after completing this seek ball impose, we receive following data. First, the data is success code. Success code, this means that if this operation has been done successfully or non-successfully. Of course, if it is done successfully, then success code is true. If non-successful, success code is false. Then the next value which he receives is направо, is his direction of the ball, direction to the ball. Next is distance to the ball, and next is speed of the ball. He receives this data as a result of the completing of this SIG-ball imposer module. So next operator is logger. So what means this logger? This logger is the operator which sends the messages. Before we have seen two places where the messages can appear in. One place is a control window. For example, during the game, you have seen in the bottom of the screen, there were 4 control windows. And inside of this control window, the messages can be sent. And also another place where the messages are sent, this is output file. So in so we put some marks about where the message must be sent. For example, if we make debug means that normally message sent to the file, because it is not very useful for us in a normal development of the game for observing in the control window. In control window, normally most important messages are sent. But in case if we want to change the way of the messaging, we can also switch on debug regime of the logger, and then the messages with debug will also go to the control window. Of course, in this case, everything will be a little bit slower because many messages will go to control window. And this way, control window only receives most important messages. But normal messages like this, they go to the output file. So next line is 517. If pressed button equals 0 equal 4 and second player timer is less than 10, then we just interrupt development of the program, and we just return back to the cycle, to the beginning of the cycle. So what this means, pressed button equal 4. Why the press button equal 4? Thing is that we have natural robot with buttons, and in the simulation we have just digital model of the natural robot. And in natural robot there are several buttons, and button number 4 is used to message to the robot that he is not allowed to kick off. Means that in the beginning of the game, if handler of the robot presses the button 1, then the robot starts playing immediately. Means that he immediately goes to the ball and immediately kick off. But in case of preset number 4, this means that a robot is not allowed to start playing immediately. And he has to wait 10 seconds before starting, start playing. And this way, pressing of the button 4, this way we message to the robot that he is not allowed to go immediately, and he has to wait for 10 seconds before starting the game. And pressing button 4, this is in natural robot, but thing is that our strategy module, which we consider here, exactly the same for the simulation robot and for the natural robot. So for this reason, we use the pressing button number 4 as a message that we are not allowed to kick off. And so for this reason, the player has to wait 10 seconds, and this is the way how it is organized here. that he, in case of the pressing button is not 4, or in case of the time is over than 10 seconds, then we proceed to the next steps of in this cycle. So the next step of the cycle is detecting direction to the guest. What means direction to the guest? The guest means that our opponents. So we play, there is our own team, means we are in home, and there is also opponent's team, which is a guest. And direction to guest means that we are detecting, we are calculating in which direction we have to make the shooting of the ball. And when we this operator is detecting direction of the shooting of the ball. Way it is detecting direction, it takes it from the vector metrics, which we put into the strategy data. So before we have made the formation of the file, which with the name strategy data, and there is a vector matrix is stored. So from this vector matrix, he pull out direction to the guest. How it pulls out? He, of course, he takes data about his own coordinate and the coordinate of the ball, and from the coordinate of the ball, he detects which section of the field has to be used for the defining of the direction of the shooting. So next two lines are for the logger. We skip them now, and the next line is 522. If distance to the ball is 0 and success score is false, means that success code is false, means that actually during observation was not find any ball in a pose, means that in a pose which is currently standing the robot, during the observing surroundings, he didn't find any ball. Of course, a robot is not allowed to observe from one pose all around surroundings. He can only observe surroundings which is in first half, in front half of his surroundings. Means that he can only observe not more than 180 degrees around himself. So he, when he make observation, he just see the sector of 180 degrees in front of himself, and if he doesn't find the ball over there, then in this case we go to the condition, and we turn the robot to 1/3 of the round from current orientation. Means that if robot doesn't see any ball, then he turns for 1/3 of the round, and again proceed for the seeking the ball. And if again he doesn't find any ball, and then again he turns for 1/3 of the round. So in case of let's say situation, we take out the ball from the game completely, and but the player continue playing, and what will be his behavior? He will be just seeking the ball. He doesn't see any ball, then turn around, then he doesn't see a ball again, and then turn around. Then this way he will be turning around and seeking the ball all the way long. So because after this turning around, he again returns back to the beginning of the cycle and again starts seeking the ball. So in case if he finds the ball anywhere, means that distance is not zero to the ball, and success code is true, and then he goes to the next steps of the current cycle. So next 4 operators, 1, 2, 3, 4. Detect is the player in fast kick position, or the player is in not fast kick position. What means that the player is in fast kick position? In case if the player, let's say the player stays looking on the goals of the opponent and the ball is in front of him, then of course, and ball is in front of him, not in a big distance, means that ball is in a short distance. In this case, the player is in fast kick position. Means that the player can immediately start undertaking approaching the ball and kicking the ball. And in case if the player is located between the goals of the opponent and the ball, means that actually the ball has more far distance from the goals of opponent than the player himself. Then in this case, the player is not in fast kick position. Means that the player has to undertake walking around the ball and to approach to the new position, which will be considered to be fast kick position. So this way, in these 4 operators which are here, we detect if the player is in fast kick position. So what means that what could happen that he is detected that he is in fast kick position? Means that if he is fast kick position, then he can do the near distance ball approach and kick, which is here. So if he appears in fast kick position, he can undertake near distance ball position and kick. So our player in this module is not allowed to just simply kick. He is before kicking, he has to make a near distance ball approach. This means that he has to undertake small steps before kicking. And in this case, when he undertakes near distance ball position and kick, he checks his relative position to the ball, and he takes his relative distance and relative orientation. So in this case, due to relative calculations, relative calculation is in a short distance is more accurate than absolute calculation. Why? Because why relative calculation is more accurate? Because a robot can detect his own coordinate, but accuracy of detecting of the coordinate, absolute coordinate, is not very accurate. It is about plus minus 15 centimeter. And this way, it doesn't worth to make accurate motions believing on absolute coordinate, because absolute coordinate is not very accurate. And in order to make accurate motions, it's worth to believe on relative coordinates, which are more accurate in case if we consider the short distances. So for this reason, near distance ball approach, he checks relative distances, and with relative distances, he approaches to the ball and then undertake the kicking. What could happen in case if we detect that player is not in fast kick position? In this case, it makes sense to undertake a far distance plan approach. So far distance plan approach, what means a far distance plan approach? Means that player takes his absolute coordinate and he undertake approaching to the new absolute coordinate, which is located in better position than he is currently standing on. For example, in case it appears that the player is standing between ball and opponent's goal, means that he has to turn around the ball and stand in other side from the ball. Then he has to walk over there, and walking over there is a far distance plan approach. And then he undertakes this far distance plan approach, and he after that he appears in new position, which is possibly to be better than current one. Why I speak possibly? Because actually during the walking there could appear various things. For example, he can fall down, or ball can be moved to a different place, or there could be some opponent's player, and then of course there are many various situations could appear during his motion. So this way I explain you how the module forward main cycle is built, so you can spend more time to study yourself with this. In case if you have any questions, you can place the questions afterwards, or you can place your questions now, and I'm ready to answer to all these questions, how to improve, how to work with this. And so if you have some questions now, please give me your questions. So do you have any questions? Because I have my plan of the speech, but I'm not sure that the plan is correct. Maybe you have some other questions. Okay, so Team Balmek doesn't have any questions. And are there any questions with other participants of the of our workshop?
I have one question.
Yes, please.
I want to understand how to change degree of ball shooting in program.
Okay, let's try to find it here. It is in, you mean the forward, right? Forward. So we have to find the forward forward main cycle. Here it is here. So let's try to see how we can change the shooting direction. Of course, first of all, our shooting is coming, appears during the near distance ball approach and kick. And here, the first argument is direction to the guest, means that this is kicking direction, final kicking direction. But what means this final kicking direction? How happened this near distance ball approach and kick? Before this near distance ball approach and kick, we see here the operator turn to course. So self turn to course, direction to the guest. Means that before performing this near distance ball approach and kick, robot performs turning to the direction of the guest. So this direction to the guest, this is actually proposed kicking direction. And then, so first of all, robots turns to the direction to the guest. Then he starts with the small steps. He starts moving closer to the ball in order to perform following kicking. Means that in case if this direction to the guest and also this yaw here and yaw here, if these yaws are equal to each other, means that he will be moving without any turning around. And if the ball is just in front of him, then he will be moving forward. If ball is a little bit in a side from the player, then he will be moving forward and to the side without changing the direction of his face. So for this reason, the best way to change, to make a different direction of the kick is that we put a different direction here, and then the same, we put different direction here. Let's say that you don't want to kick in this direction to the guest. Then how to do it? You either put here the new yaw. Let's say you can change it here, for example, to desired direction. Of course, this desired direction must be in radians. Means that radians, let's say, math p by half. Then he will be kicking to the left, straight to the left from his current. It will be straight. This way he will be kicking to the left flank. And if we put here, for example, dividing by 4, then it will be he will be trying to kick to the left corner. And if we put the minus math pi, it will be kicking to the right corner. But in this case, we have to put the same value also here. So this way, we can expect that he will be trying to kick to the right corner. So if you want that this value to be absolute, this is absolute value. Of course, we can put a relative value. For example, relative value means that there is some certain direction to the guest, but we want to add also plus okay. then it will be kicking not directly to the guest, but it will be kicking something to the left. With the half turn to the left, for example.
Okay, thank you.
I think this, hopefully this will be workable. I'm not sure that there is not any different obstacles for this. Okay, any more questions? Okay. Okay, if no more questions, then I suggest to finish our current workshop. And
no, I have also one question.
yes,
Where is can be exist global variables that can be used?
Of course, global variables must be, first of all, declared in main PBPy. For example, let's say, so here is a module main PBPy, which we this is first module, which is starting for all the package. We start from this point, and of course, initially this must be declared here. In my opinion, here must be something like a global, and then variable one, something like this. And then as soon as we declare it here, we also must to put the same variable to the other module where we are going to use it. Each model where we're going to use it, we also have to declare this this line. We have to put the same line.
Okay, I understand. Thank you.
Okay, more questions, please. But I suggest also to make different. For example, you can create additional file and put it into the file over there. Then in this case, let's say, for example, this is one instance of the packages currently is playing. Means that, okay, this package is valid for all the players in one team. And then the global variables are useful for the communication between the players of one team. You can create a global variable and exchange information between the players in one team through this global variable. And no, I'm wrong. Sorry. This is not like this. It will not work. Sorry, it will not work because for each player, referee is launching separate instance of the package. And for this reason, using the global variables will not be possible to exchange information between members of the team. Because each instance of the software is each instance of the program is separated from each other. They are running in different memory fields, and so for this reason we cannot exchange this way. But in this case, I believe there is other way. you can set up, for example, Exchange channel through the setting up file. Let's say you create file. Let's say you create file. Exchange JSON. Then this exchange JSON is a good opportunity to exchange information. Inside of this exchange JSON, you just create, for example, let's say, then
there's a more convenient way to do it. You can establish a queue from the multi-processing module. I mean, you could use some tools that are out there right now. You don't necessarily have to exchange data via files. Probably different instances will be run on different computers, and in such a situation, exchange via JSON files will be not possible. I mean, you could exchange data between processes fastly and securely, and make sure that the data is received correctly. So it seems like it's better to use multiprocessing and the existing tools of the operating system to exchange between the processes.
You mean that operating system tools?
Yeah, I mean the tools that are out there for all the operating systems, like library for Python, which is called multiprocessing. There are queues and pipes and decks and other data structures to exchange information between processes. Those are commonly used for multi-threading.
Okay, I'm not familiar with this tool, but probably yes. Maybe I need to study this tool as well. Okay, more questions, please. Okay, if no more questions, then let's proceed to the finishing our workshop, and hopefully you have enough information for the preparing your files for the competition, and I wish you a good day, and I wish you a good coming holidays, and also good success in competition. Thank you very much.